Indentation hardness by Durometer method. The shore hardness. The shore hardness is an important value to measure the hardness of a vulcanized or thermoplastic elastomer. How the test is set up and how the values are then later displayed, we will find out in this video. Generally, the hardness of materials is defined as the ability to resist plastic deformation, usually by indentation. The term may also refer to resistance to. It's the hardness property of a metal which gives it the ability to resist being permanently deformed when a load is applied. The shore hardness is displayed in different scales depending on the kind of material. Thermoplastic elastomers with soft characteristics are mostly measured in shore A, whereas harder materials are measured in shore D. Shore 00 is suitable for very soft, jelly-like materials. Each scale reaches from 0 to 100. The higher the value, the harder the material is. The shore hardness is measured with a so-called Durometer. The Durometer includes an indenter of specified dimensions which is pressed into a specimen using a defined force for a certain time. There are different geometries of the indenter available, depending on the type of material. In shore 00 measurement, the indenter more or less looks like a round hemisphere and is loaded with 1 kg weight. For shore A, it's typically used a pin with a flat tip and also a load of 1 kg, whereas shore D is measured by a pin with a very sharp tip and 5 kg weight load. We do have many further indenters which can be used for different hardness scales if necessary. While the test is executed, the depth of indentation is measured and converted directly into a hardness value by a fixed relation. On one test specimen, the hardness is always measured 3 times for 15 seconds in shore A and D testing method. Out of the 3 single results, then the median value will be calculated. The test specimen does have to measure 6 mm in thickness and a minimum diameter of 35 mm. Usually, it is punched out of a bigger sample plaque. To reach the 6 mm in thickness, it is allowed to stack up to 3 layers of thinner material on top of each other. At this point, it is also important to mention that we always have uncertainties at the changeover from one scale to another, for example from shore A to shore D. Furthermore, it needs to be considered that the shore hardness measurement with a durometer is a method for determining the material characteristics. To measure certain values directly on application parts, it is possible to use the method microshore A, microshore D, and IRHD. But keep in mind, the results are just an indicator of the hardness range, as these methods are not conducted according to the DIN ISO standard. Now you have learned more about the test method for shore hardness and its test setup in our lab. Thanks for watching the video and see you next time!